Okay, question 5.2, logarithms. Right, now, if you did A-level maths, you should know what a logarithm is. If you didn't, this may well be the first time you've done any calculation that involves logarithms. That's fine, right? Now, I'm sure Andy explained to you yesterday that all a logarithm is a way of essentially taking big numbers, or very small numbers, and converting them to a scale which is easier to handle, okay? So, for example, it's easier to write sometimes if you had 1,000,000, right? Sometimes 1,000,000 would be a big number to put on a scale of a graph. So if you take the log of 1,000,000, essentially what you're doing is you're counting the zeros. So log of 1,000,000 would be 6, okay? And that's really useful sometimes for visualizing data. Now, before we do anything with data or calculations, I need to make sure that you understand how to sort of do some basic algebraic manipulation involving logarithms using the rules that Andy gave you in the lecture. So if you don't know what the rules of logarithms are now, go back, go to Vital, get that lecture up, and I think it was in the second half of the PowerPoint slides that Andy's posted in Vital, you will have a list of rules, okay? I think actually I'm going to post them within this, because they're not here at the moment, but I'm going to put a link to them within this question as well, okay? Right, let's plow through these though. So I've got 1, 2, 3, 4, 5, 6, 7 logarithm questions. Let's just get through them, right? Right, first one, A. I'm asking you to simplify log of x plus log of x squared, okay? Right, now, so I want to take two log terms and make them into a single log term. That's simplifying, right? So the best way of doing this, well, I'm going to use my first rule of the log, which is the multiplication rule. So I know that any two logs that are added, the argument of that log, or the arguments, you can multiply together, right? So let me just rewrite that. So the rule I'm using is this one: log A plus log B equals log AB. That's the rule I'm referring to, okay? So let's try it. So I'm going to do log x times x squared, which of course is log of x cubed. Okay? Now, I also know that if I've got any log operating on something which has an index on it, then I can put this index down in front like this. That's another log rule. So I'm going to rewrite this as 3 log x. And that's simplified as much as I can. B. I'm asking you to simplify 2 log 8 minus 4 log 3. And that using the same rule. So this time it's a little bit different. I'm going to go backwards, right? So I'm going to take the numbers in front of the logs and I'm going to put them above, okay? Just so I can bring those terms together. I can't just subtract those terms from each other when they've got different multiplication factors in front of them. So I'm going to get rid of those first, okay? So let's do that. Let's rewrite that as log 8 to the power 2 minus log 3 to the power 4. Okay. Now I can use my subtraction rule. Remember what that is. That is log A minus log B is equal to log A over B. And I can rewrite this as log 8 squared over 3 to the power 4. 3 to the power 4. Okay, now, really, you could do that on a calculator, or you can just leave it as numbers. I'm just going to leave it as numbers. I know that 8 squared is 64. And I know that 3 times 3 times 3 times 3 is 81. Okay? So I would be happy leaving it like that. C. Right, I'm going to solve 2 8 plus x equals 40. Wow, now you've never had to do anything like this before. How are you going to solve an equation where x just isn't, in line? It's some sort of linear thing. It's to the power. How do I do that? Well, this is where logs come in handy, right? Because a log allows me to perform a function on a value which has an index and take the index and put it down in front of it. So in this case, the x is in the index. So I don't want it up there, I want it down there. So I'm going to take logs of both sides, right? And now it doesn't matter what log you use. You can use natural logs, which would be log to the base e. I'm going to use log to the base 10 because it's the easiest button to reach for on a calculator. You could do it in any base you want, as long as you do the same to both sides, okay? So I'm going to take logs, okay? So on both sides, I'm going to do log 2, 8 plus x, and of course, you've got to do log 40 then as well, okay? Right, now, this whole thing is the index here. Let me do that. This is the index. The whole 8 plus x is the index, so that comes down in front. 8 plus x log, and you've got log 2 left over, right? Log 40, okay? Now you can just use your basic rules of algebra. I want to get that x on its own, right? So I'm going to divide both sides by log 2, which is essentially the same as taking this underneath. That's going to be equal to log 40 over log 2. Now, I don't need to calculate that at this point. I'm happy leaving it like that, because all I need to do now is do x equals to log 40 over log 2 minus 8, right? And if I do that on a calculator, I get minus 2.68. Now that's the 3 sig fig, which is completely arbitrary. That's because I can't be bothered writing no more numbers down. 3 sig fig, I think it's going to be fine for these questions. Okay. Obviously, if you are doing calculations where you're inputting numbers that have been measured to a number of significant figures, your answer should correspond to the correct number of significant figures. Okay. Boop, boop, boop. Highlight that. Right. D. So D, I have asked you to solve. So it's a bit more complicated this time because there's an index on both sides that have an x in it, but I'm solving for x again. And this time I've got 4 minus 3x is equal to 4x plus 5. Ugh. Right, again, I'm going to take the logs of both sides. Right, so I've got essentially 4 minus 3x. So I've jumped ahead a step, right? But this is the same thing. Log 3 is equal to x plus 5 log 4. Okay. Now I'm cheating. I'm going to turn my page over because I'm cheating. I've already done them, right? But what can I do then? Well, I think I'm going to take this over here, right? So I'm going to divide both sides by log 3. That's going to give me 4 minus 3x is equal to x plus 5 log 4 over log 3. Okay, now I could work that out on a calculator, but I don't really want to. So I'm going to cheat. I'm going to call all of this alpha to begin with, which is going to save me writing it out a bit. So, and I'll work it out afterwards, okay? So you could probably work it out and then expand this out just fine. I don't care how you do it. It doesn't matter as long as you get the right answer. 4 minus 3x is equal to, I call it alpha, so it's alpha x plus 5. 4 minus, let's expand these now, equals alpha x plus 5 alpha. Okay. Now I'm going to collect these terms, right? So I want the x's on the one side and the non-x's on the other. So I'm going to get the non-x's on this side. So I'm going to do 4 minus 5 alpha is equal to alpha x plus 3x, okay? Which of course is equal to, if I put that back in brackets, alpha plus 3. So x is equal to 4 minus 5 alpha over alpha plus 3. Now, if you plug all the numbers in and you work out a value for alpha, I work out a value of 1.262 for that. I can just plug that in then. And if you do that, you plug it in here, you plug it in here, I actually get an answer at a negative value of 0.542. Again, 3 sig fig is an arbitrary significance. Okay. E. That's as complicated as it gets, guys. Right. The next one is easier. 10 to the x is equal to 50. This one you can do in your sleep, guarantee it. Take logs. Okay, x log 10 equals log 50. What's the log of 10? 1. X equals log of 50. Finished. Okay, you can write out the answer if you want. Yeah, I just realized I made a mistake in my answers. The log of 50. That'll do as a solution, right? F. Simplify this. ln2 plus ln24 minus 4 ln2. Okay, so I'm going to collect these terms using the rules. Now I think I'm going to do it piecewise, right? So let's collect these two first, right? So I know that I can use my simple addition rule for logs, even though the natural logarithms ln, it's log to the base e, right? Log to the base e equals ln. Okay, so let's add those. So that's the same as saying ln2 times 24 for ln2. That's equal to ln of 48 minus 4 ln2. Okay, so I can't use that rule yet. I can't use my subtraction rule yet because I got a 4 here. So I'm going to use the other rule and put the 4 up above first. So that's equal to ln 48 minus ln 2 to the power 4 equals ln 48 minus, what's 2 to the power 4? 2 times 2 is 4, times 2 is 8, times 2 is 16, ln 16. Okay. Now I can use my subtraction rule to get ln 48 over 16. Turns out 16 is a factor of 48. It goes into it 3 times. Answer is ln 3. You can leave it like that. G, last but not least. Okay, same thing, but I'm using y's instead of x's, right? Solve for y. 6, 3y plus 1 equals 21. Again, take logs. Log, I'll do it explicitly, right? I'll leave it there. 3y plus 1 is equal to log 21. That means I can use my log rule to get that down there. That's what I'm trying to do. I'm trying to get my y's down in line. Okay, so 3y plus 1 log 6 equals log 21. Let's do this. Let's do 3y plus 1 is equal to log 21 over log of 6. Let's get rid of this. 3y is equal to log 21 over log 6 minus 1, which means that y is equal to, bring the 3 down, factor of a third, log 21 over log 6 minus 1. Stick that in your calculator. I got a value of 0.233 to 3 sig fig. Right. The one thing I haven't done for a lot of these questions is I haven't checked the answers. Now, there's one way to know for absolute sure that you've got the right answer to these kinds of questions. Now, you are going to get these kinds of questions in a test or an exam situation, right? So if you want to be absolutely sure you've got the full marks you can get, you take this value and you put it back in here, okay? And you should get this value, right? So let's do that. So remember what we were solving first. We were actually solving this. 6 to the power 3y. This is my check, okay? Plus 1 is equal to 21. Now, all you got to do here is do this. 6, 3, 0.233 plus 1 is equal to, and you do that on your calculator, and actually I get 20.99 because I've rounded here, right? But you know that that's right then, okay? Obviously, if you do it and you get an answer which is not the same, you know you need to do it again to get those marks. Right, that's the end of that.